Okay, 5.2b, college algebra. We're still doing these three variable systems of equations, and let's do number 12. Okay, so let's notice here, we do not have the same variables in each equation. The last one we had x, y, z's in every one. Here we have a p and an r, a q and an r, and a p and a q. So we can't really combine any of these because we get rid of one variable, we're still going to have two variables left over. So it's really, really hard to do this. So what I suggest doing is when you have some like this where you have three equations but two variables in each one, like we do here and like you will in number 11 and 13 that you're going to be doing, I suggest you do substitution. And it doesn't matter which equation you decide to use for substitution. In fact, let's use this one right here. Like I say, it doesn't matter, but I would pick like one of these two. This one, this one doesn't have a number in front of it, and this one doesn't, whereas both of these do. So these two would be easier. So let's take this one, and we're going to write it as Q equals 7R plus 4. Okay, so we're going to substitute. Alright, so when we do that, we just take our Q equals 7R plus 4, and we put it in for the other equation that has a Q, which is this one. So that makes it P minus 6 times 7R plus 4 equals 1. And then we distribute. Okay, and then we get our constants, our numbers, all together, and we get that. Now notice that has the same variables that this first one has. So I'm going to focus on the first one and focus on this one I just found. So I have two equations with two variables, exactly what I want, and I know how to do this. So I'm going to multiply this thing, whoops, this is an 11, sorry, by negative 3 so that I can cancel these. So that gives me, alright, I'm going to write the first one over again. And the second one is negative 3p plus 126 equals negative 75. Add those up, that goes away. This becomes 128r equals 75, 65, negative 64. So r equals negative 1/2. Okay, so I found one of my variables. Now I go to an equation that has two variables to find my third one. Doesn't matter. I can take one of these, I can take one of these. Doesn't really matter. So let's just grab this one. So I've got 3p plus 2 times negative 1/2 equals 11. So I took this and put it in here. So 3p minus 1 equals 11. So that's 3p equals 12. So p equals 4. So now I have an r of negative 1/2. I have a p of 4. Now I'm going to look for my middle one, my q. So I go up to an equation with a q. Doesn't matter which one as long as it's got a q. So obviously I'm not going to use this one, but let's say I decide to use this one. Q minus 7r. R is negative 1/2. I don't want to deal with fractions. How about p minus 6q equals 1? Well, if p is 4, that one isn't a fraction, so I'll probably do that one. So it doesn't matter which one, but so 4 minus 6q equals 1. Negative 6q equals negative 3. So q equals 1/2. There we go. Alright, so there we go. X, Y, and Z. Okay, so remember, when you're not given all of the variables in each one. You use substitution, like I did here, and plug that in, and then you'll get 2 variables and go from there. So anyway, that'll help you for 11 and 13. Now when you get down to 15, I'm just going to leave that one for you because that's 4 equations, 4 variables, so you're going to have to get rid of 1 variable and get it down to 3 equations, get rid of another variable, get it down to 2, and then you can use your whole system of equations thing of 2 variables and 2 equations, and then again back substitute to get the answer. Alright, so let's look at a couple story problems. In fact, and I did want to throw out a couple problems from your homework. I'm having you do 1 to 15 odd. I want you to get rid of number 9, and let's see, are there any other ones? No, just number 9. And I want to tell you that number 7, you're going to come out with something weird, and that is a reminder from 5.1 of what you do when you get no solution. Okay, so number 7, the answer is no solution, so when you get to something weird, at least you know what you're doing there. Okay, page 454, middle of the page, shows you what your possible answers are, because when you're dealing with 3 variables, you're dealing with a plane. You're dealing with a 2-dimensional object here. And when you put those different planes together, you have different possibilities for solutions. Okay, so what we have been doing is one that has one solution where all 3 of those planes cross each other at one point. It shows you no solutions, infinite solutions, 2 different options of infinite solutions. Okay, so let's go to example 3 in applications, bottom of page 454. Okay, I have no idea how to pronounce that name. Moira, or let's just call her Maggie. She inherited $15,000 and invested part of it in 3 different places: a money market account, a municipal bond, and a mutual fund. So let's call those X, Y, and Z. So the money market is X, the municipal bond is Y, and the mutual fund is Z. All right. After 1 year, she received a total of $730 in interest. All right, so that's just the amount she made in interest. That's not how much she has total. She still has her $15,000 total, but they're saying after 1 year, she had $730. So she took, and then it says the money market paid 4%, the bonds paid 5%, and the mutual fund paid 6%. Okay, so how did we get $730? We took her money market, which paid 4%, times how much she invested. We took her bonds, 0.05, times her amount she invested in the bonds, plus we took her mutual fund, having to keep reading through there, times her amount she invested in there. And then at the end, she had $730. So the interest from this, plus the interest from this, plus the interest in this, gave her $730. All right, so there's one equation. What else do we know? We know that she inherited $15,000 and she invested it in 3 places. So the amount she invested here, plus the amount she invested here, plus the amount she invested here is equal to the $15,000. Okay, that's how she spread her $15,000. All right, let's see what else we have. There was $2,000 more invested in the mutual funds than in the bonds. Okay, so my mutual funds, there's $2,000 more invested here than were invested here. So this equals whatever she invested here plus 2,000, right? So this plus 2,000 would be Z. So 2,000 plus Y equals Z. Okay, so simple to fix those up. Now I have 3 equations. So now that I have three equations, I start solving. So one of the things that's good to see is this is already substituted. So what I'm going to do is 2000 plus y is equal to z. Whenever I see a z up here, I'm going to put 2000 plus y in here. And let's see what we get. 0.04x plus 0.05y plus 0.06 times my first equation. My second equation looks like this. Okay, so notice all I did was I took this and substituted it in for z, and what did that give me? It gave me two equations with two variables, an x and a y. Obviously, I'm going to combine those and move this 2000 over here and, you know, make it look a lot better so that I just have variables. So, in fact, maybe we should do that. 0.04 plus 0.05y plus 120 plus 0.06y equals 730. Okay, I'm just going to move everything around so that we get 0.04x plus 0.11y equals 730 minus 120 is going to be 610. And then at this point I would just multiply everything by 100, so that gives me 4x plus 11y equals 61000. Okay, that just gets everything so that I'm without decimals. And then I do the same thing with here. I combine everything here, and so I get, let me move things up a little bit. Trying to get all this out of here. Okay. So, here is my equation I get from this mess. Now let's work on this part right here. So I have x plus 2y plus 2000 equals 15,000. So that gives me x plus 2y equals 13,000. Now I do systems of equations with these two to find my x and my y, and I go from there, and that's it. So that should get you through 5.2.